From UFO rumors to serious science, we might finally have the best evidence yet of life beyond Earth. Meet K2-18b, a planet that could actually be home to living things. On April 17th this year, NASA dropped data that could totally change how we see the universe. They found signs of life on a distant world with a jaw-dropping 99.7% chance it's real. K2-18b is about 124 light-years away. Pretty far, but close enough for us to study. Scientists detected chemicals in its atmosphere that on Earth almost always come from living organisms. Even more incredible, these chemicals are present at levels 1,000 times higher than what we see on our own planet. If those chemicals really come from biology, just like here, then there might not just be some life out there, but a whole thriving ocean full of diverse creatures. What's wild is that K2-18b looks like a water world, completely covered in deep oceans that could be hiding life forms unlike anything we know. Flashback to 2015. The Kepler Space Telescope begins its K2 Second Light mission, scanning the depths of space. Over time, it spots more than 1,200 distant planets. But one catches everyone's eye, a mysterious world that might just be able to support life. It's about 2.5 times bigger and almost 9 times heavier than Earth. They call it K2-18b. By 2017, the Spitzer telescope joins the hunt and confirms something exciting. K2-18b orbits in the habitable zone of its star, meaning temperatures could allow liquid water to exist. At the same time, scientists in Chile, using the HARP spectrograph, measure its density, which hints at a huge ocean beneath the surface. The excitement builds. More clues keep pointing to life possibly existing there. In 2019, the Hubble Space Telescope makes a breakthrough. It detects water vapor in K2-18b's atmosphere. The idea of a deep, life-supporting ocean stopped sounding like sci-fi and started feeling real. Fast forward to 2023, and the James Webb Space Telescope, the most powerful yet, steps in to take the investigation to a whole new level. Then came the moment that blew scientists away. The James Webb Space Telescope's sensors picked up something unbelievable, traces of a chemical called dimethyl sulfide, DMS for short. Now here on Earth, this gas almost always comes from living things, like tiny ocean plants and microbes. In fact, it's one of the strongest signs we have of life. If this isn't a mistake, it could mean we've just found the first real evidence of life beyond our planet. But science is cautious. There was still some doubt. After all, the initial reading came from just one instrument. And picking out DMS is tricky. It can easily get mixed up with other gases like methane, especially in that near-infrared range. So the big question was, could this be a glitch? Just some weird quirk with the telescope's instruments? To be sure, NASA decided to run the test again, but this time using a completely different instrument, looking at the planet in a different way. If both instruments found the same thing independently, then boom, real discovery. On April 17th, 2025, the James Webb Space Telescope switched to a mid-infrared camera for a second, more detailed scan of K2-18b. What happened next stunned everyone. They detected dimethyl sulfide again, this time in amounts that could be massive. We're talking about concentrations 1,000 times higher than what we find on Earth. This isn't just any rare gas. Dimethyl sulfide is special. Back home, it's released when microscopic algae like phytoplankton start to break down in the ocean. As they decay, this gas gets released, evaporates quickly, and rises into the atmosphere. If you've ever walked along the beach on a windy day, you've probably smelled it. The unmistakable ocean scent carried on the breeze. Dimethyl sulfide, that's the stuff that gives the ocean its unmistakable smell. There's nothing else quite like it. But it's not just about the scent. This gas is super unstable. Out in the atmosphere, It only sticks around for a few days before sunlight and oxygen break it down completely. That means it can't just sit there and accumulate. It has to be constantly produced. And here on Earth, that constant supply almost always comes from living things. That's why this discovery shook the scientific world. The amount of dimethyl sulfide found in K2-18b's atmosphere is 1,000 times greater than what we see on Earth. So what does that mean? Given how quickly this gas breaks down, there's really only one logical answer. If it's coming from biology, then something alive, on a massive scale, is out there, pumping out enough of this gas to keep the atmosphere loaded with it. It sounds like pure science fiction, detecting a gas from 124 light-years away. But the James Webb Space Telescope pulled it off with an incredible trick. Every time K2-18b passes in front of its star, a little bit of the star's light slips through the planet's atmosphere. That tiny slice of light carries a treasure trove of information. The atmosphere acts like a filter, soaking up certain colors of light depending on which gases are hanging around. Those changes in the light spectrum, they're clues, fingerprints left by the planet itself. The telescope picks up those clues and sends them back to Earth. Astronomers piece those clues together, analyzing the light to reconstruct what gases make up the atmosphere. In other words, we're reading the atmospheric makeup of a planet hundreds of trillions of miles away by watching the light from its star. But to really get what's going on, we have to understand the planet's neighborhood. K2-18b orbits a star called K2-18b, a cool, red dwarf star 124 light-years from Earth. It circles this star pretty close, about 2.5 times closer than Mercury is to our Sun. But K2-2318 is smaller, cooler, and dimmer than our Sun, making the whole setup very different from our own solar system.
Thanks to a delicate cosmic balance,
K2-18b gets roughly the same amount of heat and light as Earth does. That's why scientists say it could actually be habitable. They've even put it in a new category called a Hycean planet, a theoretical kind of exoplanet proposed just a couple years ago that might be completely covered in ocean, wrapped in a thick, hydrogen-rich atmosphere. On top of that, researchers found no ammonia in K2-18b's atmosphere. That's a big deal, because ammonia would dissolve into any ocean there, so its absence actually supports the idea of a massive, watery surface. But, despite all these exciting clues, there are some serious questions and doubts still hanging in the air. If K2-18b really is covered in water, it might be way too hot enough that life as we know it just couldn't survive. The temperature, pressure, and chemicals could turn that ocean into a literal boiling inferno. And here's another twist. Some scientists, like Dr. Nicholas Vaughan over at NASA's Ames Research Center, think K2-18b might not be an ocean planet at all. Instead, it could be a small gas giant with no solid surface whatsoever. If that's true, the chances of life there basically vanish. But not everyone's so pessimistic. The lead researcher on the project, Professor Niku Madhusudan from Cambridge's Institute of Astronomy, the guy whose team first spotted the dimethyl sulfide, he's way more hopeful. He believes K2-18b really does have an ocean, and that it could be buzzing with life. According to him, within the next year or two, scientists will be able to confirm with absolute certainty if that gas is there, and if it's coming from biological activity or something else. Right now, the odds are looking good. Scientists estimate there's a 99.7% chance those signs of life are real. That's the most confident detection of a potential biosignature ever made outside of Earth. To put it in science speak, that's called a 3 sigma level of confidence, basically meaning there's just a 0.3% chance they're wrong. For comparison, when they first started looking, the confidence was only about 68%, what they call 1 sigma. But here's the catch. For scientists to say something is absolutely rock-solid true, they want a 5 sigma level of confidence. 99.99994% certainty, or just one chance in a million that it's a fluke. That's the gold standard that confirmed the discovery of the Higgs boson back in 2012. And now, that's the same level of certainty everyone's hoping to reach with K2-18b's data. Want me to explain what this could mean for the search for life beyond Earth? No matter how exciting all this sounds, scientists at the University of Cambridge are staying cautious. It's way too soon to call it a breakthrough just yet. To confidently say there's life on K2-18b, they first have to confirm that dimethyl sulfide is definitely there, with nearly absolute certainty, like 99.99994% sure. Then comes the even tougher part, proving that this gas actually comes from living things, like it does here on Earth. If they pull that off, it would be nothing short of historic, the very first real proof that life exists beyond our planet. But here's the kicker. It's not just the discovery itself that's mind-blowing, it's where that life might be found. K2-18b is only 124 light-years away. That's about 730 trillion miles. To us, that sounds crazy far. We still haven't sent humans to Mars, let alone figured out how to travel between stars. Interstellar trips might stay out of reach forever, but zoom out to the scale of the universe, and 124 light-years is basically a drop in the cosmic ocean. The universe itself stretches across 93 billion light-years. So if life pops up on a planet just 124 light-years away, it's like realizing the universe is your backyard, and the thing you've been hunting for all along was hiding in your own spare room. This could mean that life isn't rare or isolated at all. It could be everywhere. If confirmed, this discovery would flip our understanding of life in the cosmos on its head. Right now, it's still just a hypothesis, and research is ongoing. But one thing is crystal clear. Humanity has never been this close to answering one of the biggest questions we've ever asked. Are we alone in the universe? While scientists keep digging for a definite answer, it's worth imagining what life might actually look like on this mysterious world. And it makes sense to start small. On Earth, life kicked off with tiny microbes, so it's likely that if K2-18b hosts life, it started the same way. The prime suspects? Microbes that can survive in a hydrogen-rich atmosphere under intense pressure and heat. Imagine life on K2-18b starting out like some of Earth's toughest little survivors, extremophiles. These are tiny microbes that thrive in the harshest places on our planet, like deep ocean vents where temperatures soar well above boiling, past 100 degrees Celsius. These creatures don't rely on sunlight at all. Instead, they get their energy from chemical reactions, like breaking down hydrogen sulfide, a toxic gas to most life, but a feast for them. Now, picture K2-18b, with its thick hydrogen atmosphere and possible volcanic activity, as a place where these kinds of chemical energy sources could be everywhere. If life on this alien world has pushed beyond just microbes, it opens a fascinating question. What would more complex creatures look like in such a strange and extreme environment? Beneath that dense atmosphere lies a deep ocean where almost no light would penetrate. So, these creatures probably wouldn't see the world like we do. Instead of relying on sight, they might sense their surroundings through vibrations, heat, magnetic fields, or even chemical signals, just like some animals living in Earth's darkest ocean depths. And maybe, just maybe, they'd produce their own light through bioluminescence, glowing in the dark like Earth's fireflies or anglerfish. Here's where it gets really wild. Because hydrogen is much lighter than Earth's air, the environment would offer a sort of natural lift or buoyancy. That could let creatures grow way bigger than anything we know here. Imagine slow-moving giants with massive, squishy bodies adapted to handle crushing pressure and dense ocean water. Like colossal jellyfish, drifting in the warm, dark depths, or even strange, shapeless beings floating through the planet's thick atmosphere itself. Surviving the extreme pressure would be a huge challenge. K2-18b's oceans could plunge 10 to 15 miles deep, way deeper than Earth's Mariana Trench. At those depths, the pressure could be 1,600 to 2,400 times what we feel on the surface. To thrive there, animals would need some serious armor. Think of creatures with strong yet flexible outer shells, something like an exoskeleton that shields their insides from being crushed. These shells might be built from tough, dense materials, kind of like cartilage or bone, but way stronger, made from biopolymers that can handle pressure Earth's animals could only dream of. Imagine a shell not just built for strength, but smart enough to soften the blow of pressure, protecting delicate tissues inside. In other words, the creatures of K2-18b, if they exist, would be unlike anything we've ever seen. Alien giants in an ocean world shrouded by a thick, mysterious atmosphere. And all of this might be happening right now. Picture these alien creatures with bodies built like exoskeletons, but way tougher and denser than anything we see on Earth. Their outer shells could be covered in biological scales or armor that's both flexible and incredibly strong, able to handle crushing pressure without breaking. It's like nature's ultimate protective gear, designed for a world that's hostile and extreme. Of course, all of this is still pure speculation. We don't really know what kind of chemical reactions power these potential life forms' metabolisms, if they exist at all. We don't even know what their version of DNA might be, or how they pass on genetic information. But here's the exciting part. If that dimethyl sulfide gas we detected is truly coming from living organisms, it means life on K2-18b isn't just possible. It's already adapted and thriving. And who knows? Maybe right now, deep in the warm, dark oceans of that distant planet, there are creatures slowly moving about. Creatures for whom Earth is just as alien and unreachable as their world feels to us. While K2-18b currently tops the list as the most promising candidate for alien life, it's definitely not the only one. Take T-Garden-B, for example, a fascinating planet practically in our cosmic backyard, just 12.5 light-years away. Scientists think there's about a 60% chance it has Earth-like conditions. Imagine temperatures that could be moderate, maybe anywhere from freezing at 0 degrees Celsius up to a warm 50 degrees. There might be liquid water, and the climate could be fairly stable, pretty much everything you'd want to see for life as we know it. But there's a catch. T-Garden-B is probably tidally locked, meaning it always shows the same face to its star. One side bakes in constant daylight, while the other lies in endless darkness. That creates a wild temperature contrast, scorching hot on one side, freezing cold on the other. But right in between these two extremes lies a narrow zone of eternal twilight, a kind of cosmic Goldilocks area that might just be perfect for life.
Imagine a place where the climate stays just right.
Not too hot, not too cold. In this cozy zone, liquid water could flow freely, making it possible for life to exist. Maybe even complex, multicellular creatures like those on Earth. One such intriguing world is Kepler 1649c. Discovered in 2020, Kepler 1649c sits about 301 light-years away in the constellation Cygnus. That might sound far off, but what makes this planet truly fascinating are its unique features. It orbits a small, dim star, a red dwarf that's roughly 5 times less massive and 4 times smaller than our Sun. Because of this, the planet gets only about 25% of the light and heat Earth receives from the Sun. Kepler 1649c itself is a bit bigger than Earth, about 6% wider in radius and 20% heavier, so gravity there would feel pretty familiar. Not too heavy, not too light. But just like T-Garden-B, it probably faces a major habitability hurdle. It's likely tidally locked. That means one side bakes under constant daylight, while the other freezes in eternal darkness. But here's the exciting part. Right in the middle, where day meets night, there could be a narrow band with stable, Earth-like temperatures and liquid water. This twilight zone might be just the right place for simple life to take hold and thrive. Then there's Toya 700d, another fascinating contender for life beyond Earth. This planet lies about 101 light-years away in the constellation Dorado and was also discovered in 2020. It's the outermost of 3 planets orbiting the Toya 700 star. Unlike K2-18b and Kepler 1649c, which are likely stuck showing one face to their stars, Toya 700d might still spin freely. This means it could experience regular day and night cycles, which could create a more balanced, stable climate. Great news for potential life. Toya 700d gets about 86% of the light Earth receives from the Sun, just a bit less, but still enough to warm the planet. Its estimated surface temperature is around 28 degrees Fahrenheit, -4 Celsius. Definitely on the cooler side, but not unbearable. And if there's even a modest greenhouse effect, things could be a lot milder, maybe even comfortable enough to support life. Toya 700d is just a bit bigger than Earth, not dramatically, just enough to make gravity feel slightly stronger, but still well within the comfort zone for life to potentially thrive. But its size isn't the only thing that has scientists paying attention. The real bonus lies in the star it orbits, Toya 700. Unlike most red dwarfs, which are notorious for throwing violent solar flares and radiation storms, this one is surprisingly calm and stable. That's rare, and it matters a lot. A quiet star means a better shot at preserving a planet's atmosphere over long periods. That, in turn, boosts the chances for oceans, climate stability, and even life to emerge and evolve. We don't yet have a clear picture of what the surface of Toya 700d looks like, but more and more signs point to it being one of the most promising candidates for hosting life outside our solar system. And while it may be Earth-like in some ways, not all fascinating exoplanets follow that pattern. Some feel like they've jumped right out of a sci-fi novel. Take J1407b, for example, a planet so strange and spectacular that scientists are still wrapping their heads around it. Located roughly 434 light-years from Earth, J1407b has earned the nickname Super Saturn. Why? Because it doesn't just have rings, it has the biggest ring system ever discovered. And it's not even close. J1407b's rings are massive, dwarfing even Saturn's. Astronomers estimate the planet has around 30 distinct rings, stretching out to a staggering 120 million kilometers in diameter. That's about 200 times the size of Saturn's ring system. To put it into perspective, if Saturn had rings like J1407b, we'd see them lighting up our night sky, filling it from horizon to horizon. But even that majestic sight wouldn't last forever. Over time, those colossal rings would thin out as moons began forming within them, satellites pulling material from the rings as they take shape. It's a cosmic process, beautiful and temporary, and J1407b is just one wild example in a universe full of even stranger planets. What about a planet hotter than the surface of the Sun, or one so puffy and light it's nicknamed the Marshmallow Planet? How can a planet be bigger than the star it orbits? These aren't sci-fi plots, they're real discoveries. And one of the most jaw-dropping examples is located just 57 light-years from Earth. Ready to explore the weirdest, wildest worlds in the cosmos? Buckle up, space is only getting stranger.
Meet GJ54b,
a planet that's 4 times more massive than Jupiter, yet roughly the same size. But that's not what makes it stand out. What really grabs attention? It's pink. Yes, pink. Not just a rosy tint or a slight blush, it actually glows with a deep magenta hue, unlike anything we're used to seeing in our solar system. So, how does a planet end up looking like cosmic cotton candy? Well, It turns out GJ504b is still a baby by cosmic standards, only around 160 million years old. That's barely out of the crib compared to our 4.6 billion-year-old solar system. And because it's so young, the planet is still cooling off from its fiery birth. That leftover heat radiates outward, giving the planet its unique pinkish glow. It's a look that screams, "I'm fresh out of the oven." But color is only one trick in the universe's book. Some exoplanets impress, not with their glow, but with what they're made of, especially the water-rich ones. Take a Neptune-like exoplanet, often called a water world. Imagine a planet with over 8 times the mass of Earth and about a quarter of Jupiter's radius. Sounds promising, right? All that water sounds like a sci-fi dream. But don't be fooled. This isn't Earth 2.0. These planets don't have solid ground to stand on, and their atmospheres are nothing like ours. Because of the intense pressure and heat inside, water doesn't behave like it does here. There's no distinct liquid, vapor, or gas. Instead, water exists in a bizarre state called a supercritical fluid, a strange phase that acts like both a gas and a liquid, but really is neither. Temperatures can reach 280 degrees C, 536 degrees Fahrenheit. And even then, water refuses to follow Earth's rules. It's alien in every way. Now, if you think that's extreme, let's crank up the heat. In the constellation Cygnus, about 650 light-years away, there's a planet that truly redefines hot, Kepler 70b. At just 44% the mass of Earth and about 75% of its size, this tiny world packs a fiery punch. Here's the twist. Kepler 70b wasn't always like this. It used to be a gas giant about the size of Jupiter, but its host star, Kepler 70, went through a dramatic transformation. Around 18.5 million years ago, it ballooned into a red giant and swallowed the planet whole. Instead of being destroyed, Kepler 70b survived, but barely. What's left today is a scorched planetary core, stripped of its atmosphere and gas layers. It's essentially a burning hot ball of iron, having endured a cosmic inferno from the inside out. And it still orbits what's left of its parent star, now a white dwarf, closer than Mercury orbit. Scientists believe Kepler 70b is still shrinking, slowly evaporating over time. Eventually, it could get even smaller than it already is. But how hot does a planet have to be to start boiling itself away? Well, get this. Kepler 70b orbits its star 65 times closer than Mercury does to the Sun. That proximity pushes the planet's temperature to an insane 6,650 degrees Celsius. That's over 12,000 degrees Fahrenheit. Just for context, the surface of our Sun is only about 5,500 degrees Celsius. Yeah, this place makes the Sun look like a warm bath. If hell had a zip code, this would be it. And just when you think you've found the hottest spot in the universe, another scorcher enters the picture. WASP 76b, about 640 light-years away. But this planet isn't just hot, it's bizarre. WASP 76b, discovered in 2016, is nearly the size of Jupiter. It's also tidally locked, meaning one side of it always faces its star, just like the moon always shows the same face to Earth. The day side? A blistering 2,350 degrees Celsius, over 4,260 degrees Fahrenheit. That's hot enough to vaporize iron into gas. That gas doesn't just sit there, it rides on vicious winds to the planet's much colder dark side, where the temperature drops dramatically. And here's where it gets wild. As the iron gas cools, it condenses and rains back down as molten metal. That's right, it literally rains liquid iron on one side of this planet. Try packing an umbrella for that. But believe it or not, weirder planets still exist. Let's talk about PSR J1719 1438b, one of the most mind-blowing exoplanets scientists have ever come across. Why? For starters, this planet is over 3,000 times larger than the star it orbits. Yep, you read that right. And it gets even stranger. This planet used to be a star itself. Let's rewind. The exoplanet now orbits an ultra-dense neutron star, a collapsed core of a once massive star that went supernova. This particular neutron star is only about 12 miles, 20 kilometers wide, but it packs an astronomical amount of matter. A single teaspoon of its material would weigh billions of tons on Earth. And this isn't just any neutron star. It's a millisecond pulsar, spinning incredibly fast at 10,000 times per minute, sending beams of radiation through space every 5.4 milliseconds like a celestial lighthouse. Orbiting this extreme object is PSR J17191438b, a companion planet about 40% the size of Jupiter, yet somehow even more massive. The catch? It used to be a star too, but after being stripped down by its pulsar partner. So, how can something be tiny and yet incredibly massive at the same time? The answer lies in its past. The planet known as PSR J17191438b didn't start out as a planet at all. It used to be a star, but over time, a nearby, much more powerful pulsar stripped away its outer layers. What was left behind was a dense carbon-rich core, what scientists now call a diamond planet. This shimmering world is roughly 5 times the size of Earth, with a diameter of about 60,000 kilometers, around 37,000 miles. And because it orbits so close to the pulsar, the entire system, star and planet, could comfortably fit inside the diameter of our Sun. Wild, right? And space doesn't stop there. It's filled with planets so strange they sound like something out of a sci-fi dream. Take JWST, for example. This planet has the density of cotton candy. Seriously. It's about the same size as Jupiter, but only about 30 Earth masses, compared to Jupiter's 300 Earth masses. Even its core is weird, just 4 times bigger than Earth's, when it should be at least 10 times that size to support such a huge planet. Because of this, JWST-107b is extremely low in density. Think of it as a giant space marshmallow floating through the cosmos. It's so fluffy and lightweight, it's made scientists go back to the drawing board to rethink how gas giants even form. Now let's be real. None of these alien worlds, so far, seem particularly cozy for human life. But then there's Gliese 581d, a planet that just might actually be a potential candidate for future colonization. Here's why it stands out. Gliese 581d is only about 20 light-years away, basically the neighborhood, cosmically speaking. It's about 6 times as massive as Earth, placing it squarely in the so-called habitable zone of its star. That means it could have the right temperatures for liquid water, a key ingredient for life as we know it. But like many of these distant worlds, there's a catch. Gliese 581d is likely tidally locked, so one side is always facing the star and stays warm, while the other side is stuck in eternal darkness. Still, it's not a deal-breaker. Scientists believe the planet's carbon dioxide-rich atmosphere could help circulate heat around the planet, keeping the night side from freezing solid. In other words, this planet may not be perfect, but it's got a fighting chance. And when you're hunting for new Earths in a universe full of firestorms, marshmallow giants, and diamond remnants of dead stars, that's more hope than most places can offer.
Here on Earth,
we're used to the rhythm of day and night. Life evolved around it. Plants reaching for the sun, animals waking and sleeping with the light. But if we ever end up colonizing a distant planet, like Gliese 581d, that familiar cycle might be gone for good. You see, Gliese 581d always bakes under constant daylight, while the other side is frozen in endless night. So where would we live? Probably right on the edge, the narrow band between light and dark, known as the twilight zone. That's where temperatures might be just right for life. If we ever make it there, that's where we'd have to build our future. But let's zoom out, way out. Space is huge beyond comprehension. and few things show that better than a bizarre planet called 2-Mass J2126. At first, scientists thought this was a rogue planet, just drifting through the galaxy without a star to orbit. Basically, a cosmic loner. But plot twist, it wasn't alone after all. Turns out, 2-Mass J2126 is actually in orbit around a star named TYC 9486927-1. Here's the kicker: both the planet and the star were already known to astronomers. They just hadn't realized they were connected. How far apart are they? Brace yourself. The distance between them is about 1 trillion kilometers. That's roughly 7,000 times farther than Earth is from the Sun. It's the widest planetary orbit we've ever discovered. And the result? A single year on 2-Mass J2126 lasts nearly 900,000 Earth years. Imagine watching the seasons change once every million years. Now, let's come back home for a second. Jupiter, our solar system's giant, has 79 moons. So it's only natural to wonder, if these massive exoplanets are out there, spinning through strange orbits and wrapped in twilight zones, do they have moons too? Could there be exomoons, possibly even habitable ones, quietly orbiting alien worlds, waiting for us to find them? Well, let's keep going. The answers might be even stranger than we expect.
For years,
Astronomers were chasing a dream, finding moons orbiting planets outside our solar system, exomoons. But these elusive little worlds remained hidden. The reason? They're tiny, faint, and incredibly hard to spot from so far away. But finally, that chase has paid off, though not in the way anyone expected. Instead of spotting a fully formed exomoon, scientists found something even more exciting: a moon in the making. Using the powerful ALMA telescope in Chile, researchers detected a moon-forming disk around a massive young planet called PDS-70c, located over 370 light-years from Earth. This isn't just a blurry signal or a theory. This is solid, direct evidence of a swirling disk of material, rich enough to form at least 3 moons about the size of our own moon. For the first time in human history, we're actually watching the process of moon creation happen, not as a computer animation or simulation, but in real space, in real time. It's like witnessing the birth of a future solar system, and we just happen to be looking in the right direction at the right moment. Now, before we wrap up, let's talk about one last exoplanet on our list, K2-18b. At first glance, this world didn't seem too special. It's about half the size of Saturn, and when it was first discovered over a decade ago, astronomers actually passed it over. It was just too messy, too complicated, like something out of a sci-fi movie. But science doesn't give up that easily. Years later, researchers revisited the data and made an astonishing discovery. K2-18b isn't just orbiting a star, it's part of a triple star system. Here's how it works. The planet circles star A, which itself has a close companion, star B. These 2 stars orbit each other every 30 years. But wait, there's a third star, star C, also bound to the system by gravity, and it takes a whopping 400 years to orbit the other 2. It's a cosmic dance of 3 suns and 1 lonely planet caught in the middle, a system so complex it was nearly dismissed as impossible. But the universe, as always, continues to surprise us, and we're only just beginning to understand the rules of its grand design.
imagine this.
You're in a spacecraft, drifting just above the atmosphere of a distant alien world. You're right on the edge of something truly otherworldly. Looking down, you'd see a thick blanket of deep brown and smoky gray clouds swirling far below. But when you look up, get ready for a sight you'd never forget. Instead of one sun lighting up the sky like we're used to here on Earth, you'd see 2. One of them is massive, 17 times larger than our sun, a true cosmic giant. The other is a faint little companion, barely 0.5% as bright as the sun we know. And yet, despite its dim glow, that smaller star would still shine 1,000 times brighter than a full moon back on Earth. Wild, right? But as incredible as that scene is, it might only scratch the surface of what's out there. Across the vastness of space, scientists believe even stranger worlds could exist, ones we haven't even imagined yet. Some researchers think it's possible for planets to form around black holes, created from swirling clouds of gas and dust that gather in these extreme environments. Picture a planet orbiting a supermassive black hole, so far out that it takes millions of years just to complete one orbit. It sounds like science fiction, but out here, reality doesn't always play by the rules we're used to. The universe isn't just endless in size, it's endless in creativity. Every once in a while, astronomers stumble across space objects so bizarre they completely change how we think about our place in the cosmos. Think about it. After centuries of studying our own solar system, we're still discovering new surprises about the planets right next door. So, with over 5,000 known exoplanets and counting, who knows what jaw-dropping discoveries are still waiting out there. One thing's for sure, the universe isn't done amazing us yet.